Welcome back. Today's experiment is titled Experiment 5.2, Egg Denaturation Temps. So the objective for this lab is to show the different proteins have different denaturation temperatures. Also to show the effects of heating time and heating temperature on proteins in foods. We're going to be making some modifications to this lab just for the sake of videoing and of manpower and things like that. That's going to make it a little bit difficult to follow this lab as we would do it in the classroom, where we would have various lab groups doing different things. So here is our ingredients and equipment for this lab. Alright, so for this lab we're going to have a couple of pans here that we actually have already placed our water in. You can see the thermometers that are sticking out of those pans there. And behind those pans we have glass beakers. These are glass beakers that we use just for this class only, because inside those beakers we're going to be placing eggs. You can see those over there to your left. So what we're going to have to do is we're going to take 4 eggs and we're going to separate those out. And so the egg yolks of each of those 4 eggs are going to be placed in each individual beaker, and then the albumin of those 4 eggs are also going to each be placed in one of the 4 beakers. Then we're going to set the beakers or the saucepans onto the hot plates. We're going to use a medium-low heat, and we're going to watch our temperature recordings as those beakers are in a water bath. So once we get that set up, we'll come back and show you what that looks like.
Alright, ladies and gentlemen, as you can see here, we've separated again the egg whites and the egg yolks, as Miss Hall mentioned just a moment ago, into these 4 beakers. Now we're going to place these beakers into our pots, which are going to act as hot water baths for us and get this experiment started. Alright, ladies and gentlemen, so here we have this boiled egg experiment, and we're going to go ahead and give you opportunity now to record your data in data table 5.3. So we're going to start with the 60°C egg. Here's the egg white, okay? And for the appearance of the egg white, I want you to use the terms transparent, translucent, and opaque. Transparent means you can completely see through it. Translucent is that light can pass through it, but you really can't see clearly through it at what's going on underneath. And then opaque, of course, means that nothing can get through. You can't see through it and no light can get through it, okay? So just to kind of help you with this one, I'm going to let you know that this is translucent, okay? The glass is transparent, but the egg is translucent. So that'll give you a frame of reference there. And then right next to that, underneath the texture of the egg white, is this liquid. Can you say that okay in the video, Ms. Hall? Is this liquid, semi-solid, or solid? How does this look at 60°C? That's where we pulled this first one out. Okay, then we're going to move on to 65°C with the egg white. So go underneath the appearance of the egg white at 65°C. Okay, again, transparent, translucent, and opaque. I want to hold this. Miss Hall, you kind of helped me with the video there. Okay. Can you all see what's happening right down here? Can you see that okay? So this egg was starting to denature at that 65 degree temperature. The majority of it is still translucent, but we're starting to see some denaturation of that egg right down there, okay? And then so again, with the texture of it, most of it is what, but a little of it is turning into maybe that semi-solid at that point. All right, let's move on to 70°C. Here's 70. Again, you can see now that we've got a lot of denaturation of the proteins going on there. Okay, the heat didn't transfer all the way through, of course, because of the way we're cooking this egg, right? I mean, because it's, in this beaker, and we just don't have the complete heat transfer instantaneously that we would like to, but you definitely see now that at this point we've got good denaturation happening all along the sides. So transparent, translucent, opaque, and then liquid, semi-solid, and solid. Can you see that, what's happening there on the edges? Okay. Did that shot come through good? Excellent. And then here's 75 degrees. Again, just kind of Keep in mind, bear with us that, because of the way we're cooking this, it's not going to be perfect. But notice the extent of the denaturation that's happening here, okay? So still using those same words, transparent, translucent, opaque for appearance, and then liquid, semi-solid, and solid, okay? Coming over to the yolks, same idea. So here's our 60-degree yolk. Notice it's very, very much runny right here, right? The top's drying out a little bit. But these, of course, because of the coloring in there, definitely this is opaque. No light's passing through there and you can't see through it. So that's just a little bit of help with that word. Of course, you hopefully used some opaque over here a little bit as well, right? But you can see that this is really primarily still liquidy, not much denaturation happening at 60 degrees. We move up to 65, still pretty much runny all the way through, even on the bottom. Can you see that the bottom is still runny there?
We can, if you'll turn it around, we probably could see through the glass better that way, yeah. That's a little bit better.
Okay, so it's not denatured on the bottom of the beaker yet. But as we move over to, this is now 70 degrees, okay? And we're starting
to solidify there.
Starting to solidify. Now
Runny, but not near
you
as
can
runny.
see up on this end that there's some denaturing happening right in this area. Is that coming through on the video?
Mm-hmm.
Good. So it's a little bit runny, but it's starting to gel up a bit. And then finally, our 75 degrees. Look at that.
Kind of angle in this way a little bit. Yeah, there we go. A little bit easier to see.
Okay. And so, that is pretty solid for the most part there. Also, there's a little bit of yolk coming through, the runny yolk right down here that wasn't cooked all the way through there. But again, what I really want you to notice is that we didn't see good denaturation happening in the yolks until we got to up here, but we saw good denaturation happening down here with the whites. Because as I talk about the science behind the results here in just a minute, we're going to look at the fact that these proteins denature at different temperatures.
So we have 3 analysis and conclusion questions here to answer at the end. Question number 1, how does cooking temperature affect the physical property of the egg white? So look down there at your temperatures, 60, 65, 70, and 75, and tell us what happened to those physical properties. Number 2, how does cooking temperature affect the physical property of the egg yolk? And number 3, why do different proteins denature at different temperatures?
And ladies and gentlemen, when you're thinking about those physical properties, again, we're talking about things like color, texture, appearance. Those are the kinds of things that you're focusing on.
All right, and that will conclude the lab for experiment 5.2.